In this example, we're going to look at solving using the quadratic formula for this trinomial. So our first step is that we want to make sure that our equation is set equal to 0, right? Meaning that all of my terms containing constants or x's are going to be on the left side, and the only thing on the right-hand side is going to be 0. So this is taken care of for us in the first step here. So we can move on to our second step, which is identifying the a, b, and c values. The a, b, and c values are just the coefficients of the x squared term, the x term, and the constant. So our a value is 1 in this equation, our b value is 8, and our c value is 5. Once we know our a, b, and c value, we can use our substitution property and substitute those values into our quadratic formula. So we have x is equal to the opposite of b, which is 8, plus or minus the square root of b squared, which again is 8, minus 4 times a and times c. So a is equal to 1 and c is equal to 5. It's really important that when we're simplifying under the square root here that we include parentheses. So if you get easily tripped up by the minus signs or the negative numbers that we could plug into here, right, it's always best to put parentheses around whatever number you're going to substitute in. The last thing I can substitute in is my denominator, which is 2 times a, or 2 times 1. From here, I'm going to want to simplify under my square root. So I have 8 squared, which is 64. And I have negative 4 times 1, which is negative 4. And negative 4 times 5, which is negative 20. And that again is all over 2 times 1, or just 2. I'll want to simplify even further. 64 minus 20 is 44. And then even from here, we're going to want to try to simplify the square root. If you use your factor tree, right, we know 4 times 11 gets us back to 44. And 2 times 2 gets us to 4. So we can simplify the square root of 44 to 2 root 11. So we're going to take that reduced radical and plug it in for the square root of 44. So this is a specific example where our answer can be reduced a little bit more. Given the coefficients that are in each of these terms. Okay. So what we're going to focus on is our first term in the numerator, our coefficient in front of this radical, and the denominator. So just looking at these three numbers that I've circled in light blue, we can reduce fractions as long as all three of these numbers are divisible by the same number. So in this case, -8, 2, and 2 are all divisible by 2. So we can reduce this fraction by 2. So -8 divided by 2 is -4. 2 divided by 2 reduces to 1. And 2 divided by 2 reduces to 1. So again, this only works when all three numbers are reducible by a factor. If only two of the three numbers can be reduced, we can't apply that rule to simplify the answer. So now that we've reduced those terms, we're just going to rewrite this so it looks a little bit more clean. So I've got my -4 plus or minus the square root of 11, and that's all over 1, or we can just simplify it to -4 plus or minus the square root of 11.